Inequality was also part of our second week of lectures, where we explored the idea of the Kuznets curve for inequality and environmental quality. However, in neither case is the beneficial effect of economic growth guaranteed. Rather, more reliable ways to achieve poverty alleviation or environmental restoration is by means of public policy. Over the course of this series, we have focused mostly on the price instrument in both the third lecture on climate economics and the fourth lecture on optimal extraction of natural resources. Today, I want to focus more on the former and the latter categories, where we will talk a bit about awareness and education when it comes to invasive alien species, and I question why we do not use stronger command and control measures when it comes to plastic pollution. In the third lecture, we talked about the economics of climate change, where we went over several impacts such as forest fires, coral bleaching, and the damage from floods and hurricanes. I have so far been silent on ocean acidification. Ocean acidification is the result of an increased concentration of carbon dioxide in our atmosphere, where the oceans take up carbon dioxide to obtain a new chemical equilibrium between the ocean and air, which leads to a more acidic ocean. A more acidic ocean is problematic for several forms of sea life, as it hampers the calcification process that is essential to corals, plankton, and shellfish. The ocean acidification observed so far is a drop in the pH levels from a pre-industrial level of about 8.25 to 8.14 in 94. This corresponds to an increase of 30% in the concentration of hydrogen ions, as the pH scale is a logarithmic scale. The IPCC predicts that the pH levels may drop to a value between 7.7 and 7.8 at the end of the century. A study by Hall Spencer and colleagues illustrates how serious such a drop could be. Hall Spencer and colleagues used volcanic vents to investigate how different forms of life cope with varying levels of acidity. These vents naturally release carbon dioxide into the sea, creating different pH zones around them and providing a window into the ocean of the future. Their senses of the sea included species that you could see with the naked eye. In an area that was far away enough from the vents to have a pH level close to the ocean's average, they counted 69 animal and 51 plant species. As the researchers moved closer to the volcanic vents, they could observe the number of species that were still present in areas that had pH levels at the predicted level by the end of the century. Hall Spencer and colleagues reached the sobering conclusion that only 2/3 of the species were present in these acidified parts of the ocean. Ironically, the Archanoae mollusks, named after Noah's Ark, was one of the no-shows. The third lecture focused on social cost of carbon estimates, and I questioned how serious we should take estimates from Nordhaus, his dice model. Due to the model's damage assumptions, he seems to prefer rolling the dice with our climate. We also explored alternatives to setting a Pigouvian carbon tax equal to the marginal cost of carbon by considering an average cost of carbon instead. However, during the last weeks of discussions with my students over recent working papers, we concluded that the Paris consistent carbon tax would constitute a minimum desirable tax. In my focus on the social cost of carbon, I had neglected an idea from Nordhaus's lecture on climate clubs. I considered this idea to look for a coalition to push for more ambitious climate change targets a more promising idea. The idea of climate clubs sits at the intersection of cooperative and non-cooperative game theory. Let us watch an introduction by the SciShow.